A particle of mass m is projected towards a point O. So it is projected towards the point O. Now, something as simple as this. See the way I've actually written down the same thing. Okay? But one of them's going left and the other one's going right. That really messes up your whole idea of what's negative and what's positive, doesn't it? It can really confuse you at the start, right? So what we're going to do is we're going to do one of them where phi is minus root 5 over 3. And then I'm going to attempt another method that has phi as plus 5 over root 3 and see if it makes a difference. Okay? Now, it's going from a point, a particle mass m is projected towards a point O with initial speed root 5 over 3 from a point P, which is 3 meters away. Okay? So that is 3 meters away there, okay? So 3 meters away. Now, the particle is repelled by a force of magnitude 4m over x cubed, where x is the distance from O. Show that the equation of motion is v dv equals 4x to the minus 3 dx. Okay, what we got to remember is, in this equation, as it comes towards point O, it's slowing up. The reason being is the acceleration force is in the opposite direction to the motion. And if this is the case, what we can say is force equals ma. And please remember, it's a differential equation. So force equals plus 4m over x cubed. Mass is m. A is defined as the acceleration. A is now dv dt. Okay? But in this equation we want it in terms of dx. Unlike the last question where s is the distance, in this one x is the distance. So what we're going to say is a equals dv dx by dx dt. And dx dt is distance, the change in distance over the change in time. That makes it v dv dx. Okay? So now we're going to have mv dv dx. What will happen is the m's will cancel on both sides. And what we should get here is we'll get v dv equals 4x to the minus 3. Just bring up using the equation of Innes dx. Put in your integral signs on both of them. Now, I need to figure out some limits. Okay, so the limits are going to come from, well, we know when that's v, that's x. That's okay. It's finding the lower limits, which is the problem. Okay. At the start of the question, it's 3 meters away from O. So x equals 3. The velocity is root 5 over 3. But we have to remember is it's minus root 5 over 3. Is that alright? Minus root 5 over 3. So that's where the tricky part comes in. Now the rest of it is actually quite simple. Okay, this here is when I add on 1, it's going to be x to the minus 2. When I differentiate that, I need another minus 2 outside to fix the integral there. So that's perfect. And that's going to be x and 3. And this part here is going to be phi squared over 2. Phi to minus 5 root 5 over 3. Now, did I prove the first part? I did prove the first part, by the way. That was proved back there. Okay. Find how close the particle will get to O. Okay. To find out how close we'll get to O, what I'm first going to do is I'm just going to get phi in terms of x. Okay. I'm just going to continue to do what I've done the last 2 exercises. So I'm going to get this here. It's the same thing as minus 2 over x squared. And I'll change it like that. So it's going to be minus 2 over x squared minus 2 over 9. equals phi squared over 2. Now, if I square that, I'm going to get 5 over 9, isn't it? Plus 5 over 9. So it's minus 5 over 9 divided by 2, which is actually 5 over 18. Okay, so it's going to minus 2 over x squared. So excuse me. Minus 2 over x squared plus 2 over 9 equals phi squared over 2 plus 5 over 18. What we got to do next is
minus 5 over 2.
I'm going to bring the 2 over 9 over to your side. It's going to become minus
5 over 18.
minus 5 over 18, excuse me, you're right. So it's minus 5 over 18. Bring the 2 over 9 over to your side. Now 2 over 9 is the same thing as 4 over 18. And that's basically going to become minus 9 over 18. So it's going to be phi squared over 2 minus 9 over 18. And minus 9 over 18 is minus a half. And now we're at minus 2 over x squared. I'm going to multiply both sides by 2. I'm going to get minus 4 over x squared equals phi squared minus 1. Now, I really want to get v on its own. The reason why I want to get v on its own, it's dv dx was what I had at the start, and that means v in terms of x. So just remember your goal, okay? So bring over the 1. I'm going to get 1 minus 4 over x squared equals phi, and phi equals the square root of all that. Now, that's my question done, near enough done there. Now, what it wants to ask me next is, find out how close will the particle get to zero, get to O. What is how close it'll get? How close it'll get is when is phi 0. Okay, go back down. Phi is now 0. This means 1 over 4 over x squared equals 0. Okay? This means that 1 equals 4 over x squared. X equals plus or minus 2. Okay? Now why can't x be minus 2? Sorry? Yeah, it's not going to go backwards, okay? So it's at the start it's 3 meters away, and when phi turns into 0, it's 2 meters away. So the answer is 2 meters. Okay? So x equals 2 meters. It gets 2 meters away. Now, the next one. Find its speed when it has travelled half the distance from P to the nearest point. What's half the distance? It starts off 3 meters away. It ends up 2 meters away. X is 2.5. It's roughly 2.5. It travels 0.5, but x is defined as displacement away from O. So x is 2.5. Okay? So in this question, x is 2.5 because x is defined as your distance away from 0, from the point O. So x equals 2.5. Phi therefore is equal to the square root of 1 minus 4 over 2.5 squared. Put all of that straight into the calculator and you're going to get phi equals 3 over 5. Phi equals 3 over 5 ms to the minus 2. Sorry, ms to the minus 1. It's a velocity. Okay. So that's that one done.